In this project, our objective was to take the classic Bomberman game and train a bot to play it. For this, we used Pommerman, a version of Bomberman built for machine learning competitions. In the game, there are 4 players in a free-for-all competition. They can move around the map and place bombs. Bombs destroy obstacles and kill enemies. When a bomb destroys an obstacle, a power-up can appear to aid the player in winning. The last player standing is declared the winner. This gameplay shows 4 instances of the game's default bot playing. This is called Simple Agent. For this task, we chose to use reinforcement learning. Reinforcement learning has some key elements. First, the environment, which in our case is the game map, with the position of bombs, opponents, and other game elements. Watching the environment, there's an interpreter, who compiles the game state and gives it to the agent. That is our bot. From the game state, the agent chooses an action, which can be moving, bombing, or even doing nothing. The interpreter is then responsible for rewarding or punishing the agent's action, guiding him towards good actions. There are several ways to train an agent. One of those is to directly learn a policy function. A policy takes in features of a game state and outputs an action. Optimal policies are very complex, thus neural networks are used to model them. Therefore, we need some way to train the network parameters. We chose to use proximal policy optimization. PPO is a policy gradient method, meaning that it takes the rewards and uses them to calculate an approximate policy gradient. This is then used for gradient descent and the policy is updated. Our first attempt at a baseline solution used classic PPO. The rewards of the game's default, 1 for winning, -1 for losing, and 0 otherwise. Since the board is an image, we use a convolutional neural network for the policy and let it train for some days.
3 days later.
The agent got a 14.8% win rate. However, this is the result. The agent decided he would just stand still and hope the other agents kill themselves. So we tried a simpler approach, use a neural network to predict what the simple agent's action would be given a game state. We call this agent Kakashi, the copy agent. This agent was trained by classic supervised learning with data annotated from 1000 games won by the simple agent. Kakashi got a 17% win rate and behaves very similarly to the simple agent. So we decided to train Naruto. During the first stage of training, Naruto learns to play like Kakashi, getting a reward for doing the same as him. In the second stage, he gets the default reward, trying to learn how to win on his own, but with a better starting point. Naruto also got a 17% win rate, but he learned something more interesting. He learned how to run away.
E morreu.
Our final agent has the same idea as Naruto, but with a different implementation. We switched from PPO to A2C, another policy gradient method. Then, we directly train the policy network as we train Kakashi to set the initial policy. This is more efficient than having the agent learn the rewards. Finally, we trained with reinforcement learning and the result was a 59% win rate. We named him Naruto Sennin, as he is just like Naruto but way stronger. He basically learned to wait in his corner for the enemy. He also doesn't use bombs. However,
turn down for what?
will the Naruto agent become Hokage someday?